So the next thing that we need to look at is adding and subtracting positive and negative fractions as we go through our rational number operations. Just like when we added and subtracted decimals, the first thing we want to do is apply those rules for addition or subtraction of integers so that we know if we're adding or subtracting those fractions. Then, of course, we use the fraction rules that we're already very familiar with for the actual addition or subtraction. And then finally, to get our final answer, we use our integer rules to decide if the final answer is positive or negative. Okay, so here we are with our first set of addition with using fractions. So I didn't see any reason to start with fractions or mixed numbers that had the same denominator because you should know how to do those. So we're going to use these fractions that have different denominators and also some mixed numbers. Now I like to use, when I add and subtract, I use, whoops, I wasn't expecting that. Sorry, folks. Move that back. Okay. So I like to use the acronym I love eating apples and avocados. I love eating apples and avocados. And I make myself this nice convenient chart, and I goes over here, love eating apples and avocados. Now eventually you probably will just remember what to do, but for now this is what we're going to do. So the I stands for improper fractions. Now in this particular case, we don't need to change these to improper fractions because they're already fractions. But when we have a mixed number, we need to make sure we use that I. So I'm going to have 1/4 plus 2/3. My next step is my L, and I can write these down here just so you know. So I've got improper fractions. That's step 1. Step 2 is the LCM. We, of course, are looking for the least common multiple of those denominators. So in this case, I'm looking for the LCM of 4 and 3. Least common multiple, or the number that both 4 and 3 go into. Those are those gazintas you've heard me talk about. 4 goes into 3, 4 goes into 12, and 3 goes into 12. So the least common multiple is 12. Now the E stands for equivalent fractions. Because that's my next step. Right here, step 3 is my equivalent fractions. Actually, I'm going to take that 3 out of there so you don't think it's something that you need to do. But I will leave the E there because that is our step. So our equivalent fractions. Well, since I know both of them have to end with their denominator is 12, I'm going to go ahead and put those in there, and I know I'm adding. So 4 becomes 12 by multiplying times 3. So I multiply 1 times 3. My numerator is 3. 2/3, I know that 3 becomes 12 by multiplying it times 4. 2 times 4 is 8. So my equivalent fractions are 3/12 plus 8/12. Now my next A is that I'm going to write over here, step 4 is to add or subtract the integers. Because now I can simply ignore my denominators, and I've got 3 plus 8. I know that 3 plus 8 is 11, because that, of course, is an easy one. And then my step 5, my other A, is that I've got my answer, which I might have to reduce. So again, I-L-E-A-A, I love eating apples and avocados. Well, even if you don't, you could pretend you do so that you remember this. So my answer, I'm going to take the answer from my addition in this case of those integers is 11. My least common multiple is the number that goes on the bottom. So there's my answer. In this case, I don't have to reduce it. It's simply done. So next, I'm going to do this next problem. I just wanted to change some of my colors so that they could be differentiated one from the other. So in this case, I've got negative 2/5 plus negative 1 7/8. So I want to go ahead and sing my song. If the signs are the same, find the sum. Okay, here I am. I'm finding the sum because the signs are the same. So now that I know that, I don't need to worry about those integer rules yet. I'm simply going to go ahead and apply my fraction rules for addition of fractions. So again, I love eating apples and avocados. So the first thing I know I'm going to do is I'm going to make improper fractions. I'm going to ignore those negative signs for this moment. Okay, so 2/5 is going to remain 2/5. Excuse me. I didn't like how that looked. Okay, so I'm going to have 2/5 and 1 7/8. I need to make that into an improper fraction. I've got 8 times 1 first. I'm going to add that to 7. 8 times 1 is 8, plus 7 more is 15, so I've got 15/8 as my improper fraction. The least common multiple, I'm looking at both of the denominators. I've got 5 and 8. So the least common multiple of 5 and 8 is 40. Equivalent fractions. I know I need to make equivalent fractions for both of these. So I've got 2/5. I need to make to some number over 40. I'm going to bring those negative numbers back. It's a negative number plus some other negative number over 40 as well. So I ask myself, how do I get from 5 to 40? I, of course, multiply times 8. 2 times 8 is 16, so it becomes negative 16. And I ask myself, how do I get from 8 to 40? It is multiplied times 5. Now, I know some of you have noticed that both times I simply multiplied the denominators by each other. Got to be careful of using that as your rule, though, because it might not always be the case. In fact, some of the numbers coming up, you'll find that. So anyway, 8 times 5 is 40, so I multiply 15 times 5, that's 75. So now my next A, I'm going to add, but only the numerators. So I'm going to have negative 16 plus negative 75. I am running out of room, so I am going to slide this over here. Just give me a moment to fix this. So again, that's negative 16 plus negative 75. And I already have established that its signs are the same. Find the sum. So it's those absolute values. 16 plus 75. I know that 16 plus 75, well, 75 plus 6 is 81, plus 10 more is 91. The signs were the same, so therefore it's negative 91. And now I go back and I take my top number is negative 91, and my bottom number is 40. Now, that is my answer, my final A, but don't forget, sometimes I need to reduce. In this case, I do, because 91 is much larger than 40. That little 40 can't hold up 91. So I say to myself, how many 40s go into 91? Well, I know that that's 2 times, because 2 times 40 is 80. 91 take away 80, well, that leaves me with 11. keep the denominator the same, bring down my negative sign. So my answer is negative 2 11/40. Moving right along with a different example, I can see that I've got my signs. Signs are different. Find the difference. I'm finding the difference for this one. But I am still going to use my acronym. I love eating apples and avocados. Yummy! Mrs. De Silva loves both of those. So my first thing that I'm going to do, I've got my I. So improper fractions. I'm going to have 5, 6. And I've got 1 and 1/4, ignoring the negative for now. So I'm going to do 4 times 1 is 4, plus 1 more is 5. So that's 5/4. Set up my chart. I've got my L, least common multiple of 6 and 4. Now remember, just a while ago I told you that this case we wouldn't be just multiplying the 6 times the 4. Well, we want to keep that in mind. I've got 6 and 4. The least common multiple of 6 and 4 is 12. I'm going to set up, I'm going to go down to E. E is equivalent fractions. So I know I've got some number over 12 plus some other number over 12. I know that my second number is negative. So I say to myself, how do I get from 6 to 12? Well, 6 times 2 is 12. I do that to the numerator. 5 times 2 is 10. I say to myself, how do I get from 4 to 12? Well, that's times 3. And I know that 5 times 3 is 15. And in this case, it's negative 15 because I did bring that negative down because it does belong with it. So I've got my I, my L, my E. I forgot to label the E. I've got an A. I'm going to add, or in this case, subtract as usual. Oh no, I'm not subtracting yet. Those are coming. I'm going to add as usual. So I've got 10 plus negative 15. The signs are the same, find the sum. If the signs are different, find the difference. I already figured that out, but I want to double check. So I've got my absolute values of 10 and 15. I know that negative 15. I know that negative 15 is going to have a larger absolute value, so I'll put that one first. 15 minus 10 gives me 5. I take the sign of the larger absolute value, which is right there, negative 5. And now I've got my numerator and my denominator. So my final answer is negative 5/12. This does not need to be reduced. It already is in its lowest term. Okay, so moving right along, I'm changing some colors here, so again we can differentiate between the two. So here we are. Whoops. I've got this time negative 1 3/8 plus 1/6. I'm going to have my chart set up. The first thing I'm going to have is my I for I love eating apples and avocados. So improper fractions, I'm going to have 1 3/8. 8 times 1 is 8, plus 3 more is 11/8. And 1/6 is already in its lowest term, so there that is. My L, the LCM of 8 and 6. The LCM of 8 and 6 is 24. Next is my E, equivalent fractions. So I'm going to have some number over 24 plus some other number over 24. I know my first fraction is negative. So I'm going to say to myself, how do I get from 8 to 24? That would be times 3. My numerator in this case is 11. 11 times 3 is 33. I've already placed my negative sign in front of it. The next thing I have to say to myself is, how do I get from 6 to 24? In this case, that's times 4. My numerator is 1, and 1 times 4 is 4. I'm going to now get to my a, add those integers as usual. Negative 33 plus 4. The signs are different. Find the difference. Here they are. So I'm going to find those absolute values. Absolute value of negative 33 is 33, minus the absolute value of 4 is 4. 33 minus 4 is 29. The one with the larger absolute value is 33, so that's negative 29. So negative 29 is my numerator. 24 is my denominator. That is my answer. However, this time it does have to be reduced because 24 is too little to hold up 29. 24 goes into 29 one time with 5 left over. 24 remains in the denominator, and it is still negative. There's your final answer. So I now have 4 examples of addition, and we're going to now move on to subtraction. Again, I've been keeping these numbers the same right through, just changing it from addition to subtraction. So the first one I have is 1/4 minus 2/3. So I am going to set this up just like I've set up all the others. First thing is my I love, I can write that up here again. You want to keep saying it so you don't forget it. I love eating apples and avocados because they are very yummy. So in this case, again, neither one of these need to become improper fractions, so I am going to have 1/4 and 2/3 remaining just as they are. The least common multiple is my L of 4 and 3 is 12. I know that I'm going to have some number over 12. This is my E, equivalent fractions. Some number over 12 minus some number over 12. So I say to myself, how do I get from 4 to 12? That is times 3. 1 times 3 is 3. How do I get from 3 to 12? That is times 4. The numerator here is 2. 2 times 4 is 8. Now I go to my A, which is add or subtract. It is in fact this time subtraction. So I'm going to have 3 minus 8. I'm going to apply those rules. Stay, change, change, cha-cha-cha. Stay, change, change, cha-cha-cha. Don't forget to cha-cha-cha so you can get it right. And now the signs are different. Find the difference. Absolute values of both. Absolute value of negative 8 is 8, minus the absolute value of 3 is 3. 8 minus 3 is 5. I look at the larger of the two absolute values. It is negative 8, so therefore my answer is negative. And now I've got my negative 5 as my numerator. That last part is my answer. And my denominator is 12. So my final answer here is negative 5/12. Next problem. We're moving right along. I'm again changing my colors that I'm using just to make it easier to see the both of them. So here I am. I've got negative 2/5 minus negative 1 7/8. My first step is improper fractions. 2/5 already is. It's not an improper fraction, but it's not a mixed number, so we don't have to change it. I've got negative 1 7/8. 8 times 1 is 8, plus 7 more is 15, so that's 15 over 8 is my improper fraction. Next, I've got L. The LCM of 5 and 8 is 40. Next is my E, equivalent fractions. So I'm going to have some negative number over 40. minus another negative number, also over 40. I say to myself, how do I get from 5 to 40? That's times 8. The numerator times 8. 2 times 8 is 16. I bring this right down. 8 times what is 40? 8 times 5 is 40. And then I've got 15 times 5, which of course is 75. My next step is my A, add or subtract as usual. In this case, I've got negative 16 minus negative 75. I'm subtracting. I get to cha-cha-cha. Stay, change, change, cha-cha-cha. Don't forget to cha-cha-cha. And signs are the same, find the sum. If the signs are different, again, from the second part, this we're not looking at anymore. These signs, of course, are different. So I'm going to be finding the difference. Absolute values of both. The absolute value of positive 75 is going to be larger, so 75 minus the absolute value of negative 16 is 16. 75 minus 16. Well, if I have 75, I take away 10. That leaves me to 65. Take away 6, that gets me to 59. I take the the sign of the larger absolute value. That is 75, so that's positive 59. So my numerator is going to be positive 59. My denominator is going to be 40. That is my final answer. However, it does need to be reduced because 40 is much too small to be holding up that big giant 59. So how many times does 40 go into 59? It goes into it once, and I've got 19 left over. So my final answer is, don't forget the positive, positive 1 and 19/40. Almost through all of our examples. Here we are. Acronym up top. I love eating apples and avocados because they are yummy. So I start with my improper fractions. 5, 6 remains as it is. 1 1/4. 4 times 1 is 4, plus 1 more is 5/4. Let's set up my chart. The least common multiple, that's my L, of 6 and 4 is 12. I'm going to bring that right down for my E, equivalent fractions. I'm going to have some number over 12 minus some negative number also over 12. How do I get from 6 to 12? Well, I multiply times 2. Multiply that numerator times 2. 5 times 2 is 10. now I'm on to 4. 4 times what is 12? That, of course, is times 3. Multiply the numerator times 3. 5 times 3 is 15. My next step, I'm going to add or subtract as usual. So I've got 10 minus negative 15. I get to stay, change, change. Stay, change, change. Cha-cha-cha. I've got simply 10 plus 15. That gives me now a positive 25. Here we are. This is my numerator, positive 25, over my denominator, which is 12. I need to reduce that, even though it's my final answer, because 12 is much too small to be holding up that big giant 25. So 12 goes into 25 2 times. 2 times 12 is 24, so that means I have 1 left over. It is positive, so my answer is positive 2 and 1/12. Okay, we're on to the last example that we're going to have for this particular series on adding and subtracting integers, or rational numbers, excuse me, in this case fractions. So my first step, of course, is my I, which is improper fractions. 8 times 1 is 8, plus 3 is 11. So that's 11 eighths. And 1/6 can remain as it is. Okay, next thing I'm going to have is my L, the LCM of 8 and 6. The LCM of 8 and 6 is 24. So I know in my next step, I'm going to have my E, equivalent fractions. I'm going to have some number over 24. In this case, it's already a negative number, negative something over 24 minus some other number over 24. How do I get from 8 to 12? Excuse me, 24. 8 to 24 is times 3. I look at my numerator, that's 11. 11 times 3 is 33. That's my numerator here for this improper fraction, or equivalent fraction. How do I get from 6 to 24? Well, that's times 4. 4 times that numerator is 1. 4 times 1 is 4. So I'm going to add or subtract as usual. In this case, I'm going to have negative 33 minus 4. I get to stay, change, cha-cha-cha. So I am going to stay, change, cha-cha-cha. And then I'm going to have an addition problem. I get to sing again. If the signs are the same, find the sum. Oh, look at that. They are the same. Again, I'm finding that sum of the last expression that I've written. I'm not looking at this one anymore. So I find my absolute values. Absolute value of negative 33 is 33, plus the absolute value of negative 4 is 4. 33 plus 4 is 37. Both of those were negative to begin with, again, in that second expression, the one that I wrote that was an addition problem. So my answer is negative. And here I am, this is my numerator, negative 37 over my denominator, which is 24. I do need to reduce that because 24 is too little to hold up 37. How many 24s are there in 37? There is 1 24 in 37. 37 take away 24 is 13. That's what's left over. The denominator stays the same, and I can't forget that negative sign. So my final answer is negative 1 and 13/27. So there you have it.